Here's question number 61. A metal forms BCC crystal lattice with density 100 gram per centimeter cube. If the H length of its unit cell is 100 picometer, then the number of atoms of the metal present in 200 gram of the crystal is. Basically, in this case, we have the BCC, body centered cubic crystal lattice. And for this system, we have the value of Z, that is 2. It means one unit cell has 2 atoms present there. The density we have, density is 100 gram per centimeter cube, and the edge length, that is A, it is also given. This is 100 picometer. Density is given in gram per centimeter cube. Let's change this 100 picometer in centimeter also. What we need to do here, just multiply 10 raised to the power minus 10 to it to get the value in centimeters. It would be 10 raised to the power minus 8 centimeter. This is the edge length. Now with the help of this, we can find out the volume. What would be the volume? Edge length cube. That would be 10 raised to the power minus 24 centimeter cube. This is the volume. Density you have, volume you have calculated, mass you can find out easily. Density is equals to mass by volume. So mass is equal to density into volume. This is the mass in gram. Now, this is the mass for one atom only. Now, we just want to find out the number of atoms present in 200 gram of the crystal. So, we have the total mass, that is 200 gram, and we have the mass of one atom. Now, this is the mass of the unit cell, and we know that in this case, we have the total mass, that is 200 gram. So, let's find out the number of unit cells present here. That should be equal to 200, that's the total mass, divided by mass of one unit cell, and that is 100 into 10 raised to the power minus 24, or simply you can write here 10 raised to the power minus 22. This is the number of unit cell. Now, what would be the number of atom? We know that one unit cell contains 2 atoms, so the number of atoms present here would be equal to 2 into 200. That's divided by 10 raised to the power minus 22, and this would be equal to 4 into 10 raised to the power 24. Where this is given? This is given here in option 1. That's why I'll choose it as the correct answer. Now after this, it's a turn for question number 62. Which is incorrect for negative deviation solution? Let's check the given options. Delta H for mixing is less than 0. Yes, it's true for the negative deviation solution. Then delta G is negative. Then delta G of mixing is also less than 0. It is also true. For the delta V of mixing is also less than 0. But if we talk about the change in entropy for the mixing, that should be more than 0. Because if we mix something, there is the increase of the randomness, and as increase in the randomness is there, definitely this delta S value for the mixing should be positive. It means it should be more than 0, not less than 0. And on that basis, this is incorrect for negative deviation solution. And that's why the answer is option 4. Let's take next question. Question number 63. Which change will increase the vapor pressure of 0.5 molar aqueous NaCl solution? In this particular case, we have to find out that particular change which will increase the vapor pressure of 0.5 molar aqueous NaCl solution. We should always know that whenever we talk about the increase in vapor pressure, that can be increased by decreasing the number of solute particles present in the solution. So if you decrease the number of particles present in the particular solution, vapor pressure would definitely be increased. How this process can be done? This process can be done by dilution process, by addition of water, by increasing the volume of the solution. So that increase can be done by addition of water to that particular solution. And if you add water, there would be less number of the particles in given volume, and definitely there would be the increase in the vapor pressure. And this is the correct answer for our question also. Now after this, let's take next question. Question number 64. the temperature independent concentration term is. We have different concentration terms given here and we have to choose that concentration term which is temperature independent, that does not depend on temperature. So if we consider the concentration term in which volume is there, that volume is always temperature dependent. And if your concentration term include the volume, then definitely it would be changed by change in temperature. So in case of molarity, that is equal to moles of solute upon volume of solution. It will be changed by temperature. For the normality, if we talk about percentage weight by volume, in this case volume is also there, so it would be temperature dependent. But if we talk about the mole fraction, that is equal to the ratio of the moles of particular substance to the total number of the moles present in the solution. So this does not include volume and definitely it is temperature independent, and that's why I'll choose it as the correct answer. Now after this, question number 65. If 8% weight by volume solution of glucose is isotonic with 2% weight by volume solution of non-electrolytic solution, then the molar mass of A is. In this case, solutions are isotonic. It means the osmotic pressure of solution of glucose is equal to osmotic pressure of another solution that contain non-electrolytic solute A. So it should be there. And we know that pi is equals to CRT. On the basis of this, we can say that C, that's a concentration for glucose solution, into RT should be equal to the concentration for the solution of non-electrolytic solute A, RT. These RT should be cancelled out. It means the concentration of glucose should be equal to the concentration of the solution of non-electrolytic solute A. Now, the concentration in terms of molarity we take here. If we consider that 8 gram of glucose we are taking, its mole we can calculate dividing it by its molar mass. Further, it is divided by the volume of the solution. That volume you are taking here, let's assume 100 ml because it is 8% weight by volume. So 100 ml it is, and it would be divided by 1000 also. It should be equal to the concentration of this solution, that is of non-electrolyte solute A. We don't know the molar mass of this, but we know the amount of this. This is 2% weight by volume, that's why I'm considering it 2 gram. That should be divided by the molar mass of this solute. Further, it is divided by the volume that we are considering here, 100 upon 1000. This term can be cancelled out. It means 8 by 180 is equal to 2 by molar mass of that solute, and this molar mass would be equal to definitely 2 into 180 divided by 8, and that is equal to 45 gram per mole. If you calculate it, you will find out this value is 45 gram per mole, and this is your answer also. And let's choose the correct answer that's given here in option 3. And now after this, it's a turn for next question. That's question number 66.